Next, concurrency result 4. Concurrency of the perpendicular bisector of the side of the triangle. See, the perpendicular bisector of the sides of the triangle are concurrent, right? So ax1y1 bx2y2 plus cx3y3 with the given triangle, right? Altitude is different from perpendicular bisector of the side, right? Note that point. So altitude is from one vertex to the other side. The line from one vertex to the other side which is perpendicular to the opposite side, right? The other side means opposite side, right? But here just we are taking the perpendicular bisector, just the line which is bisect the side, right, in two parts, and which is perpendicular to that side, right? The side of the triangle is the line perpendicular to that side and passes through the midpoint of that side, right? That is the point. So DEF be respectively midpoint of the side BC, CA and DAB. So DEF are midpoints. See the coordinates of D, we know midpoint formula, x2 plus x3 by 2, y2 plus y3 by 2. Similarly, E x3 plus x1 by 2, y3 plus y1 by 2, and F x1 plus x2 by 2, y1 plus y2 by 2. Now draw the perpendicular bisector DP, right? So this is the perpendicular bisector of the side BC, and EQ perpendicular bisector of the side AC, and F R perpendicular bisector of the side AB. So we know the slope point form, right? Y minus y1 equal to m into x minus x1. That is equation number 1. And also we know the slope of the perpendicular line which is perpendicular to the line joining the point x1 y1 and x2 y2 is minus x2 minus x1 by y2 minus y1, right? So we are now going to write the equation of the perpendicular bisector DP, EQ and FR. So DP is perpendicular to BC. The slope of DP is m is equal to minus x3 minus x2 by y3 minus y2, and it is passes through the point D, x2 plus x3 by 2, y2 plus y3 by 2. So we are going to use the slope point formula, right? So equation of DP is y minus y1. Instead of y1 is in the formula. Here y1 is y2 plus y3 by 2, which is equal to m into minus x3 minus x2 by y3 minus y2 into x minus x1, right? x2 plus x3 by 2. So taking LCM, 2y minus y2 plus y3 by 2, which is equal to minus x3 minus x2 by y3 minus y2 into 2x minus x2 plus x3 by 2. So 1 by 2 on the other side, and the right hand side and left hand side get cancelled. So you will get 2y minus y2 plus y3, which is equal to minus x3 minus x2 by y3 minus y2 into 2x minus x2 plus x3. So just y3 minus y2 is the in the denominator of the right hand side, just cross multiply. So you will get 2y minus y2 plus y3 into y3 minus y2 minus x3 minus x2 into 2x minus x2 plus x3. So keeping so we are going to write x term, y term and constant term. So 2y into y3 minus y2 minus y3 plus y2 into y3 minus y2 minus x3 minus x2 into 2x plus x3 minus x2 into x3 plus x2. So 2 into x3 minus x2 into x, right? So we are bringing that x term and the constant term on the right hand side to the left hand side, and write it in the standard form, x term, y term, constant term. 2x3 minus x2 into x plus 2y3 minus y2 into y. So we are having y3 plus y2, a minus b into a plus b, y3 square minus y2 square minus x3 square minus x2 square equal to 0. That is equation number 2. So similarly we can write the other perpendicular bisector equations. So equation of EQ is equal to, so in the cyclic form you write it in the, so 1 instead of 1 you put 2, instead of 2 put 3, instead of 3 put 1. So if you are having x3 put x1, If you are having x2, put x3. If you are having y3, put y1. If you are having y2, put y3. Right, like that. If you are having x1, put x2. So replace that, you will get the other equation. 2x1 minus x3 into x plus 2y11 minus y3 into y minus y1 square minus y3 square minus x1 square minus x3 square equal to 0. That is equation number 3. So equation of FR is 2x2 minus x1 into x plus 2y2 minus y1 into y minus y2 square minus y1 square minus x2 square minus x1 square equal to 0. Fourth. So now we are going to prove these three lines are concurrent by using determinant method, row diminishing. Write the coefficient of xy and constant term. So like this, first equation or equation number 2, x coefficient is 2x3 minus x2, y coefficient is 2y3 minus y2, that is in the first row, right? Minus y3 square minus y2 square, constant term, minus x3 square minus x2 square. Similarly, write it for third and fourth equation. Now we are going to prove this is equal to 0. So the idea is so 2 is common, take it outside from first column, second column, you can cancel that one. So this is equivalent to this one, right? So cancel means you can divide it by 2, right? C1 divided by 2, C2 divided by 2, C3 as it is, right? Now you are going to take the idea R1 can be replaced by R1 plus R2 plus R3. R2 and R3 are same. So first row, so you will get 0 because x3, x1, x2 minus x1, x2, x3. So cancel. Similarly, second row, first column, third row, first column. In third row, first column, you will get y1 square minus y1 square, y2 square minus y2 square, like that. So 0. So completely one row is 0, therefore determinant value is 0 by the property of determinant. Therefore, the perpendicular bisector of the sides of the triangle are concurrent. So, but this point of intersection of this perpendicular bisector of the sides of the triangle is called circumcenter of the triangle. Thanks.